Welcome. Today we're going to unpack something really fundamental to our digital world. Controlling who and what gets onto our networks.
Right.
And maybe just as importantly, what they can actually do once they're connected.
Yeah, absolutely. And, with so many devices floating around now and threats always changing, it's pretty critical stuff.
It really is. And we know folks want to get up to speed on important topics quickly, but, properly. So that's what we're aiming for here. We've looked at some fairly detailed technical sources on this.
We have. And the idea is to pull out the key concepts, what really matters in practice, without everyone feeling like they need an engineering degree.
Exactly. So the mission, if you like, is to get a handle on the basics of network access management, why it's such a big deal now, and the different ways organizations are tackling it.
Sounds good. Where should we start?
Well, let's start with the gatekeeper itself. What exactly is network access control, or NAC?
Okay, so NAC.
Yeah.
Think of it as a really smart bouncer at the network door. Its job is to figure out who the users and what the devices are trying to get in. But it doesn't stop there. It also figures out what resources they should be allowed to touch once they're inside.
So it's identification, authentication, authorization.
Exactly. Those are the core functions. Plus, ongoing monitoring. It's about knowing what's there, making sure it's legit, controlling what it does, and keeping an eye on it.
Got it. So more than just checking IDs, it's deciding who gets backstage access too.
Precisely.
But why is this so much more crucial today? I mean, connecting to Wi-Fi used to feel simpler.
It did, but the whole network scene is just messier now. That's a good word for it from our sources.
Messier how?
Well, first, just the sheer number of devices. Think about BYOD people using their own phones, laptops.
Right. Bring your own device.
Yeah. And then there's the whole Internet of Things explosion. Smart everything, TVs, lights, cameras.
Even fridges.
Exactly. And all these things have wildly different security levels built in, or sometimes not much at all.
So loads more potential doors for trouble to walk through. That's where what part of NAC comes in, identifying all these gadgets.
Spot on. Then add mobility. People aren't just working inside the office building anymore.
No, they're everywhere. Home, coffee shops.
Airports, you name it. So that old idea of a safe inside network and a dangerous outside, it's really blurry now. The perimeter isn't what it used to be.
Makes sense. The boundaries are dissolving.
They are. And on top of that, the threats themselves are getting smarter. Attackers love going after endpoints, your laptop, your phone, because that's often the easiest way in.
So a compromised device connects, and suddenly the attacker has a foothold inside.
That's the nightmare scenario, yeah.
And I guess there are rules and regulations pushing for this, too.
Oh, absolutely. Compliance is a huge driver. Think IPAY for healthcare, PCI, DSS for payments, GDPR for personal data.
Right.
They all demand really strict controls over who can access what data, how networks are segmented. NAC is a key tool for actually enforcing those rules.
Okay, so it's security, it's managing all these devices, dealing with mobility, and ticking the compliance boxes. Sounds powerful, but complex.
It definitely can be. Setting up NSC isn't trivial. You're touching lots of different parts of the network, integrating with identity systems. It needs careful planning, because if you get the policies wrong, you could end up blocking people who should have access.
Yeah.
Which is not ideal.
No, definitely not. Okay, so let's break down what NAC actually does to achieve its goals. We touched on the goals: better security, compliance, visibility.
Right, automation, enabling things like BYOD and IoT safely.
And the functions are how it does that. You mentioned identification and profiling first.
Yeah, that's step one. Discovering anything that tries to connect and figuring out what it is. Is it a Windows laptop, an iPhone, a printer, a camera? Sort of like tagging everything.
Okay, finding out what's knocking on the door. Then authentication.
Then authentication. This is verifying that the user or the device is who or what it claims to be.
Proving identity.
Exactly. Using passwords, maybe digital certificates, sometimes even just the device's unique hardware ID, the MIC address.
Okay, so once you're sure who it is.
Then comes authorization. Based on who they are, what are they allowed to do, what servers can they reach, what applications can they use. This is all policy-driven.
So my phone might be allowed on the guest Wi-Fi, but definitely not allowed near the financial systems.
Precisely. And linked to that is posture assessment.
The health check.
Yeah, the device health check. Before letting it fully connect, NAC checks if it's compliant. Is the OS patched? Is antivirus running and up to date? is the firewall on?
Like checking for digital germs before letting it mix with others.
That's a great way to put it.
So if it passes the health check.
Then you get to policy enforcement. This is where NAC actually applies the rules. It might stick the device onto a specific virtual network segment of VLAN.
Like putting it in the right digital room.
Exactly. Or it might apply specific traffic filters, access control lists, ACLs saying exactly what it can talk to.
Setting the rules for who it can talk to in that room.
You got it. And it doesn't stop there. There's monitoring, watching what devices do after they connect, looking for anything weird.
It's digital neighborhood watch.
Kind of. And finally, remediation. If a device fails posture check or starts acting suspiciously later, NAC can take action. Maybe block it, or, more likely, put in quarantine a sort of penalty box network with limited access. Maybe just to update servers or a help page.
So it can guide users to fix the problem or isolate the device. It's managing the whole connection lifecycle.
That's the idea.
Yeah.
But, and this is important from our analysis, NEC is really powerful for controlling that access point.
Right.
But it's not a silver bullet for everything after connection.
Right. It needs to work with other security tools.
Definitely. Which we can get into. But maybe let's dig into authentication first. How does it actually verify identity?
Good idea. Authentication is foundational, right? If you get that wrong.
The rest falls apart.
Yeah.
Right. And the sources point to a few main methods. The big one is often 802.1x. Sounds technical.
It is a standard, i.e. E802.1x. It's generally seen as the strongest method for wired networks and Wi-Fi.
Okay. It involves 3 bits. The supplicant, that's software on your device.
Like my laptop.
Yep. The authenticator, that's the network device, like the switch you plug into or the Wi-Fi access point. And the authentication server, usually something called a radius server.
So laptop asks, switch checks, radius server confirms.
Pretty much, when you connect, the switch initially blocks everything except this 802.1x chatter. It asks your device, who are you? Your device answers. The switch passes that to the radius server.
The switch is like a middleman.
Exactly. The radius server then does a challenge response. It asks for proof, maybe a password or better, a digital certificate. There's some back and forth using a protocol called EAP, Extensible Authentication Protocol. It's the language they use for this. Finally, Radius says, okay, they're good, or nope, block them. If it's good, Radius tells the switch to open the port for normal traffic.
So it's a secure handshake before the door fully opens. You mentioned EAP methods.
Yeah, there are different flavors of EAP. Some use certificates on both ends, like EAP TLS, which is very secure. Others create a secure tunnel first, then use simpler credentials inside, like PEEP or EAP TTLS.
And this is way better than just a shared Wi-Fi password, like WPA2 personal.
Oh, much better. Because everyone, or every device, uses unique credentials. Not one password shared by everyone.
Makes sense. So 802.1x is the top tier. But what about things that can't do 802.1x, like printers or cameras?
Right. Lots of those simpler devices don't have that supplicant software. For them, there's a fallback called ANO 2-point bypass, or AMBI.
AMBI? Okay.
It uses the device's AMC address, that unique hardware ID. The network tries 802.1x, gets no reply, so it just grabs the MC address and sends that to the Radius server, basically asking, is this MC address allowed?
So the username and password are just the MSC address itself?
Essentially, yes. Radius checks its list. If the MSC is on the list, access granted.
That sounds less secure. Can't you fake a MAC address?
You absolutely can. That's the big problem with MAB. MAC spoofing is relatively easy. So our sources stress MAB is really a last resort.
So if you have to use it, like for an old printer you can't replace yet.
Then you need other controls. Put those MAB devices on a really restricted VLAN. Use tight ACLs, allowing them only the access they absolutely need. Maybe use device profiling to try and spot if a device claiming a printer's address suddenly looks like a laptop.
So lock it down as much as possible.
Exactly. And try to phase out devices needing MAB over time.
Okay, so 802.1x, MAB-B, and then captive portals. I see those all the time for guest Wi-Fi.
Right. Captive portals are web pages for authentication, great for guests or onboarding new personal devices. You connect, try to browse, and boom, you're redirected to a login page.
The one asking for an email or a voucher code or just to accept the terms.
Yep. You interact with that, maybe log in or just click accept, and that information goes to a back-end server. If it's okay, the NIC system updates your access, often telling the switch or AP to let your traffic through, maybe onto a specific guest VLAN.
Seems user-friendly for temporary access. Any technical gotchas?
A few. Reliably intercepting web traffic, especially encrypted HTTPS traffic without scary browser warnings, needs careful setup. And sometimes they use map caching so you don't have to log in constantly, but that can sometimes cause issues if you move around a large Wi-Fi network.
Right, so it sounds like a mix and match approach often makes sense for authentication. 802.1x, where you can map carefully where you must, portals for guests.
That's generally how it plays out, yeah.
Okay, so we've authenticated. Now, authorization, defining what they can access. You mentioned dynamic VLANs.
Right, so instead of manually configuring switch port 23 for the engineering VLAN, port 24 for sales.
Which sounds tedious and error-prone.
It is. With dynamic VLAN assignment, when someone authenticates successfully, the Radius server tells the switch, okay, this user's in sales, put them on VLAN 20 automatically.
Ah, nice. So the port itself doesn't matter. The user's identity determines their network segment.
Exactly. It enabled policy-based segmentation. All guests go to the guest VLAN, marketing to marketing VLAN, etc.
And the benefits? Security, I assume.
Big time. Isolating groups limits lateral movement for attackers, but also operational efficiency. Network admins aren't constantly repatching or reconfiguring ports when people move desks. Supports that colorless port idea. Any port works. Policy follows the user. And flexibility, too.
Okay, so VLANs provide broad segmentation. What about finer control, access control lists, ACLs?
Yep, NAC can push down dynamic ACLs, too. Again, based on the authentication, Radius can send specific filter rules to the switch or access point for that specific user session.
So even within the sales VLAN, maybe only certain users can access the main sales database server?
Precisely. ACLs work at the IP address and port level, so you can get really granular. Enforce least privilege, only allow access to exactly what's needed. Use them for quarantine and ACL that only allows access to update servers. Great for locking down IoT devices too. Maybe a camera only needs to talk to the video server, nothing else.
That offers much more surgical control, and this ties into role-based access control, RBAC.
It does. NAC often integrates with directory services like Active Directory. When you log in, NAC sees you're in the finance managers group. The NSC policy says, okay, finance managers get VLAN 30 and ACL finance manager rules.
So the role dictates the VLAN and the specific permissions via ACLs.
Exactly. It simplifies administration. You manage roles, not individuals.
Yeah.
It ensures consistency. It aligns network access with business structure. And it's great for compliance audits.
Okay, that authorization piece with VLANs, ACLs, and RBAC makes a lot of sense. Now, the posture check, the device health check, why is that so critical?
Well, because even an authorized user can be a risk if their device is compromised, right?
Sure.
If your laptop has malware or it's missing critical security patches, letting it onto the main network is asking for trouble. Posture assessment is about ensuring the device meets a minimum security bar before it gets full access.
Stopping the infection at the source, what kinds of things does it check?
Common checks include, is the OS the right type and version? Is it fully patched? Is antivirus installed, running, and definitions up to date? Is the firewall on? Is the disk encrypted? Sometimes even, is specific unwanted software installed?
That's quite a list. How does it perform these checks? Do I need special software?
Sometimes. There are agent-based methods where software, either permanent or temporary dissolvable, runs on your device and reports back.
Okay.
And there are agentless methods where the NSE system tries to check things remotely using network protocols or by talking to management systems. Agents usually give deeper visibility, but agentless is less intrusive. Pros and cons to both.
Right. And if my device fails the check, say my antivirus is out of date.
That's where remediation or quarantine kicks in. Access might be denied outright, but more often, you're put into that restricted quarantine VLAN.
The penalty box.
Yeah. From there, you might only be able to reach update servers to fix the issue, or a portal with instructions. The user usually gets a notification explaining what's wrong. Once it's fixed, you try again.
So it guides the user to become compliant. Okay, we have authentication, authorization, posture. How does NEC actually enforce all this? Are there different models?
Yes, broadly speaking, there's pre-admission and post-admission control, and often a hybrid.
Pre-admission. That sounds like checking before you let them in.
Exactly. All the checks, authentication, maybe posture happen before the device gets any real network access. It's proactive security. Stop problems before they start.
Makes sense. Like the bouncer checking ID before you enter the club.
Right. The potential downside is if the checks are too complex or slow, it can impact the user experience, or if policies are too strict, You might block legitimate access by mistake.
Okay. And post-admission?
Post-admission grants some initial access, maybe after basic authentication, but then relies on ongoing monitoring. If the posture check fails later, or suspicious activity is detected after connecting, then enforcement actions happen, quarantine, blocking.
So let them in, but watch them closely.
Pretty much. The upside is potentially a smoother, faster initial connection. The risk is that a compromised device has a window, however small, to do harm before it's caught.
I see. And hybrid.
Hybrid tries to get the best of both. Maybe strong authentication and basic checks pre-admission, followed by continuous monitoring and potentially deeper posture checks post-admission, with the ability to dynamically change access if needed.
That sounds most robust. Checking at the door, but also keeping an eye on things inside.
It generally is, yes. It offers layers of control.
Now, you mentioned earlier that NEC works best when it's not alone. Integration with other security tools?
Absolutely essential. NEC integrated with other systems creates a much stronger security posture. It allows for sharing context, better threat detection, and automated responses.
So the whole is greater than the sum of its parts. What tools does it typically talk to?
Key integrations include firewalls,
Yeah.
especially next-gen firewalls and GFWs. NEC can share user identity and device posture info with the firewall, so the firewall can apply rules based on who the user is, not just their IP address.
Identity-aware firewalls.
Oh, intrusion detection prevention systems, IDPS. If an IDPS spots malicious activity from an endpoint, it can tell NEC to quarantine that device immediately.
Automating the response.
Exactly. SIEM systems, security information, and management. NSC sends its logs there for centralized correlation and analysis, helps spot bigger trends, and provides audit trails.
The central security brain.
Sort of, yeah. Endpoint detection and response, EDR, or traditional AV. NSC can check if EDR is running. EDR can tell NEC if it finds a threat on a device. It's often a two-way street.
Makes sense.
Vulnerability management systems.
Yeah.
NAC can use vulnerability scan results as part of its policy decisions, maybe deny access if critical vulnerabilities exist. And MDM or UEM systems, mobile device management or unified endpoint management. NAC can leverage the device inventory and compliance status of the MDM UEM.
Wow. Okay. So NSC acts like a central enforcement point, using intelligence from all these other tools to make smarter decisions.
That's a great summary. It orchestrates access control based on a much richer set of data.
Now, different companies make NAC solutions, right? Our sources compared a few, like Cisco, Aruba, Fortinet, Forescout, Sophos. Any key differences jump out?
There are definitely differences in focus. Some, like Cisco IZ or Aruba ClearPass, integrate very deeply with their own networking hardware. Others, like Forescout, are often highlighted for their strength in agentless discovery and visibility across diverse, multi-vendor networks, especially for IoT and OT. Fortinet fits well within the Fortinet security fabric.
So it depends on your existing gear and specific needs.
Absolutely. Are you heavily invested in one vendor? Do you need really strong IoT profiling? How important is agentless versus agent-based? Scalability, management complexity, licensing models, they all played a role in choosing the right fit.
Not one size fits all. And implementing any of these must have challenges.
For sure. We mentioned complexity earlier, just integrating with everything. Handling the sheer diversity of devices, especially BYOD and weird IoT stuff, is tough. Ensuring compatibility with older network gear can be tricky. And it's not set and forget. It needs ongoing tuning and maintenance.
I can imagine the help desk calls if it goes wrong. What are the keys to doing it right? Best practices.
Plan meticulously. Start a monitor-only mode first. See what would happen without actually blocking anyone. Refine policies. Define user roles clearly for RBAC. Figure out how to handle those tricky non-802.1x devices using profiling and segmentation. Don't just rely on MOD alone. Keep monitoring and tuning the policies, and automate where possible through those integrations.
Plan, crawl, walk, run. Makes sense. Can we look at how this plays out in different industries? Like, how does a hospital use NAC versus a university?
Good question. The core functions are the same, but the emphasis changes. In a typical corporate network, it might be about segmenting employees from contractors, enforcing BYOD rules.
Okay.
In healthcare, HIPAA is huge, so protecting patient data is paramount. NAC is used heavily to secure access to clinical systems and also to profile and secure connected medical devices, infusion pumps, monitors, etc.
Right, can't have those being insecure.
Definitely not. In education, you've got a massive number of diverse users, students, faculty, staff, guests, often with their own devices, across large campuses. So scalability and robust BYOD guest management are key.
Different priorities, same underlying tech, and we touched on compliance. NEC helps tick those boxes.
Yes, significantly. For things like PCI DSS needing network segmentation, or HIPAA needing access controls, or various government frameworks like NIST, NEC provides the technical controls to enforce policies, segment networks, ensure strong authentication, check device health, and log everything for audits. It automates a lot of what auditors want to see.
So security improvable compliance, that's valuable. Looking ahead now, where is NEC technology going?
It's evolving, definitely. Big trends include tighter integration with zero trust architecture. NEC is a key policy enforcement point in zero trust.
Right, never trust, always verify.
Exactly.
Yeah.
Also, cloud-based NSE, or NSE as service, is growing, simplifying deployment and management. There's a huge focus on better IoT and OT, operational technology, security, deeper device profiling, understanding behavior, micro-segmentation, more automation, integrating with SR platforms, and convergence with broader security frameworks like SASE and SSE, blending network access with cloud security.
So becoming even more integrated and intelligent.
That's the direction, a dynamic policy engine for the modern borderless network.
This has been really illuminating. It's clear network access management is way beyond just passwords now. NSE is that vital control layer for today's messy, threat-filled landscape.
It really is. And it's not just about locking the door, is it? It's about intelligent control based on identity, device health, context, every step of the way.
Yeah, understanding these building blocks definitely provides a solid foundation for thinking about network security today. It certainly makes me think more about how these principles apply, even personally.
It should. Which leads to a final thought, maybe.
Right.
As those lines between our work networks and personal networks keep blurring, how sure are we, really, about who and what is connected to our critical resources and what actually happens after they connect?
That's definitely something to think about. Food for thought, indeed.
Thanks for joining us.
And be sure to check out the show notes for links.
Until next time.
See ya then.